In this video, you will learn how to use theoretical and experimental probability to make predictions. Now, theoretical and experimental might sound like some pretty big words, but let's break them down and talk about what they are. If you look at the word theoretical, you can see it has the word theory as part of it. Theoretical probability occurs when all possible outcomes are equally likely, and then you can find the probability by taking the number of favorable outcomes divided by the number of possible outcomes. This is a lot like what you've already done. The probability of something and the theoretical probability of something is pretty much the same idea. And then we have experimental probability, which has that word experiment in it. So we actually have to conduct an experiment and find out what number of times we get each outcome. Its probability is based on repeated trials of an experiment. And to write down the experimental probability of an event, you figure the number of times the event occurs over the number of trials that you run. Let's look at theoretical probability of flipping a coin. So we want to find the theoretical probability of flipping a coin and getting heads. Well, we know that the probability of flipping a coin and getting heads is 1 out of 2, or 50%. But how many times would you expect to flip heads out of 30 flips? So for theoretical probability, we're taking the actual probability and predicting how many times we think we'll get a certain outcome. So we're going to use the probability that we figured out earlier, the 1/2 and also the 50%. We can set it up as a proportion and say 1/2 equals what number out of 30? Or you could think of it kind of like an equation, and we figure what is 50% of 30? And you can write out the x equals 0.5 times 30, or what is 1/2 of 30? No matter what way you actually solve this, you should get x equals 15 times. Whether it's a proportion, or if you use an equation, what is 50% of 30? You would also get 15. How many times would you expect to roll a 2 out of 30 rolls? When you roll one die, there are 6 possible outcomes. It could be 1, 2, 3, 4, 5, or 6. But getting a 2, there's only one favorable outcome. So we would say the probability of rolling a 2 is 1/6, or 16.67%. Now be careful, that 16.67% might be a little deceiving. We do not get that by just changing the fraction bar to a decimal. That is 1 divided by 6. Try it in your calculator, 1 divided by 6. But then you have to move it, times by 100. Since we know the probability of rolling a 2 is 1/6, we can set that up as part of a proportion, and the whole is 30 rolls. We're trying to figure out how many rolls would be a 2 out of 30 rolls. It should be proportional with 1/6. So solving that proportion would give us 5. We could expect to roll a 2 5 times out of 30. And if working with percents and decimals is more up your alley, you could try it like this. What is 16.67% of 30? And when you figure that out, you should get 5 times also. How many times would you expect to roll an odd number out of 100 rolls? Your odd numbers here are 1, 3, and 5. So there are 3 favorable outcomes and 6 possible outcomes. We still have 6 possible outcomes because it could be anywhere from 1 to 6. But the only ones that would be odd would be those 3 different numbers, 1, 3, and 5. So 3 out of 6, that's the same as 1/2, or 50%. The probability of rolling an odd number is 50%. As a proportion, we might set up 3/6 equals what out of 100, or 1/2 equals 1 out of 100. Either one will give you the same answer. Or, of course, what is 50% of 100? And no matter which way you solve this, you're going to get 50. So how many times would you expect to roll an odd number out of 100 rolls? You can expect to do that 50 times. Let's do an experiment. So now we're moving on to experimental probability. A bag contains an unknown number of blocks that are 4 different colors. Draw out 20 blocks and replace them, and record the results. Go ahead and tally these up as we draw. Green, green, yellow, another green, red, yellow, green, green, and red. Here are the other 10. Green, yellow, green, green, yellow, yellow, green, yellow, green, green. We've tallied up the results, and it looks like we have 1 blue block, 6 yellow blocks, 11 green blocks, and 2 red blocks. For blue, 1 favorable outcome out of 20, so 1/20th. Yellow had 6 favorable outcomes out of 20, so 6/20ths. Green had 11 favorable outcomes out of 20, 11/20ths. And red had 2 favorable outcomes out of 20, 2/20ths. A couple of these can be simplified. 6/20ths can be simplified to 3/10ths, and 2/20ths can be simplified to 1/10th. Now we're going to use the results of this experiment to make some predictions. What can you predict is the probability of the next block you draw being red? What about blue? Or what about green or yellow? When we did the experiment, we drew out 2 blocks that were red out of 20, or 1/10th of the blocks we drew out were red. So that is the probability, 1/10th. We drew out 1 blue block out of all 20 blocks. So that's the probability of drawing a blue, 1/20th. The next one is, what's the probability of pulling a green or a yellow block? So kind of like if to win a game, you had to either get a green or a yellow. So we can add together the probability of drawing a green, 11/20ths, or drawing a yellow, 6/20ths. And when we add those together, we get 17/20ths. We added those together because out of all 20 blocks that we drew out, 11 of them were green and 6 of them were yellow. So out of all the blocks, 17 were either green or yellow. Okay, one last one. If you were to draw a random block and replace it 100 times, how many would probably be yellow? You could use either 6/20ths or 3/10ths for the probability of drawing a yellow. And the rest of the proportion would look like this, because if we drew 3 out of 10 as yellow, how many out of 100 would be yellow? If you drew out a block and replaced it 100 times, you could expect probably 30 of them to be yellow. Now you should know how to use theoretical and experimental probability to make predictions. Thanks for watching.